table. The easiest, the most straightforward types of limits are the ones that you can evaluate just by plugging in the number. So could we plug in 2 into the original one right here in the top left? Could we plug in 2 right there? Yeah. Can we plug in 0 into that one? Like, what is the limit as x goes to 0 of 2x plus 3? It's 3, right? Can you plug in 0 there? Oh, you can't. So sometimes the table is going to be super, super helpful to give you an idea numerically what's going on these. Now, Liana, you said this. So again, table set is second window. And you get something, yours might look a little different. So take a minute right now, everybody, and see if you can get your table to look just like that on the screen for the first two, because you can plug in numbers like into that one. What's the limit? 3. So you know it's going to be around 3. In this one right here, let's decide it's 1 over x. So if we were going to use this numerically, if we're going to do this numerically, we need to change the function from x squared to, well, I'm going to clear it first, to 1 divided by x, like this. So if I wanted to do the table set, if I wanted to be around 0, well, where would I want to start my table? Negative, like what? Negative, pick a number. Negative what? What's a little bit less? Negative 0.5, sure. And maybe a table set, 0.01. Would that work pretty well? Let's see what happens. The challenge is going to be, it's going to show one side of it, right? Oh, it's interesting. It's going -2. It's getting more negative, it's getting more negative, it's getting more negative, right? But we want to get closer to 0. So if we want to get closer to 0, maybe what should we do on our table set here? Start where instead of negative 0.5? Start where? That's farther away. We want to get closer to 0. Negative what? Negative 0.1. Negative 0.1 maybe, right? Yeah. So let's do the table now. Oh, look at that. That's fantastic, right? What's going on? It's getting really, really, really negative, right? What does this suggest the limit is as you go to 0 from the left? As x approaches 0 from the left, what does this suggest is going on? Yeah?
It goes to negative.
It's going down infinitely, right? It may seem like it stops at negative 100. Is it stopping at negative 100? No. So what we could do is we could go to negative 0.01, right? We could go to negative 0.01. And what would we have to change? That would be where we start, negative 0.01. Sorry, I got to put a point in there or it's going to be really hard. Like this. And what should I change the delta table to? 0.001, right? And if we do the table here, look what happens. Do they get even bigger? Yeah. Well, bigger and negative. So that suggests as x goes to 0 from the left, it goes really down. Now, if we wanted to change this, if we wanted to go the other direction, if we wanted to go on the other side, what could we do instead? We could start at what? If we wanted to see the positive side, point what? 0.01. Let's just change it there and see what happens. It's going to start really big and then get smaller, right? It's going to start really big and get smaller. You know what the graph of 1 over x looks like, don't you? You know what it looks like? Yeah. What does 1 over x look like? It goes like this, and it goes like this. So as you go to 0, here's 0 right here, what's it doing? It's going down, right? As you go to 0 the other way, it's going up. Take a look. As you get closer to 0, if you go the other direction this time, right? It's getting really, really big. So if we zoomed in even further, would we see the exact same numbers but positive? Yes. So you can use your calculator to fill in these tables. You can use your calculator. What happens as you approach x from what side? The left. So if you approach x, which is 0, if you approach 0 from the left, can you tell me what the output is getting infinitely close to? How high is the point? As x goes to 0 from the left, what output does it approach? It approaches 0, exactly. It approaches 0. It does, in fact, approach 0. What about 0 from the right? What happens if you're on this function and you approach 0 from the right? What does it approach? It approaches 2. Remember, it's not asking what does it get to. It says what does it get infinitely close to. This approaches 2. Now here's your first example of a certain jump discontinuity. Well, when you approach 0 from the left, it's 0. When you approach 0 from the right, it's 2. If I just ask you, what happens as you approach x, as x approaches 0, what would you say? What? What does D and E represent mean? Does not exist. Why do we say it doesn't exist? This is asking what happens as you go from both sides. If you get to different numbers on both sides, you will always say the limit doesn't exist. There's notice how there's no side there. That means the left and right have to agree in order for that to be a number. So if the left doesn't equal the right, you say Danny used a great term, DNE. 2, not 0, sorry. 2. He said DNE, which means does not exist. They don't do this, but they should. Think of it as having parentheses around it. It's not the limit and then plus 4, it's the limit of that whole thing. So can you plug in 2? Yeah, so what's that going to equal? 8, exciting. Can you plug in -1 into this one? Yeah, sure, it's a polynomial, right? What's the domain of any polynomial? All real numbers. You can plug all numbers into any polynomial. Not a rational function, but a polynomial. No dividing by another polynomial. Well, you get 3, -1 squared, plus 2, -1, -1. So what do you get? 3 minus 2 minus 1. What's that going to be?
0.
Yeah, can you have 0 as a limit? Absolutely. So always check to see if you can plug things in. It's a cheap, cheap trick. What about this one? Can you plug 2 into this? No. But what should you do at this point, Maggie? So here's the thing. If you come across one you can't plug the number into, check to see if you can simplify it into something you can. You can plug it into. So Maggie, if I factor the bottom here, I end up with the limit as x goes to 2. What's the, oh wait, stop, top stays the same. What's the bottom become? X plus 2. So if you were just graphing this, if you were graphing this right here, you would say the domain of this function is what? What is the domain of that function? X such that x can't be 2 or -2. Does anything cancel?
Yeah.
This cancels, leaving you with what? So you have a limit as x goes to 2 of 1 over x plus 2. Hey, can you plug in 2 into that? So that's going to be 1 over 4. Because you canceled the term on your last test, what would that mean exists at x equals 2? A hole. What you've done by canceling is plug that hole. You plug the hole. You haven't changed the limit. All you've done is added 1 point. So technically speaking, this function isn't identical to this, but it behaves the same way for limits around 2. You've plugged the hole. That's all you've done. So if you run across a function that you can't plug the hole into, see if you can do some sort of simplification. Now what's the best, not the best, but what's your primary method for simplification right now? What did you do first? You factored, right? You factored. Factoring is going to be key. Is that the only thing you're going to do? No. There's all the other things you've learned, like division and all sorts of manipulations, and I'm going to teach you some new tools. Okay, you can sit down. It's written out here. It's written out here in a few ways. If you try to plug in 2, or get close to 2, you end up with something infinitely big or infinitely small. So you get these indeterminate forms where it's 0 over 0 or infinity over infinity. If you run into those things, can you plug a number in? No. Sometimes you think to yourself, oh, I have something that's really small, and I'm multiplying it by something that's really big. And you're like, what happens? So what happens if x is going to 0, and let's say y is getting infinitely big, and I multiply them together? Do you have any idea what happens for sure? No. Like if they're going to battle, well, 0 could win, theoretically. Infinity could win, and it could get infinitely big. Or they could come to like a stalemate, and the answer could be like 4. When you get to a situation with 0 over 0 or infinity over infinity, in this case, as x goes to 2, what happens to the top? What does the top get infinitely close to? It gets infinitely close to 0, right? What does the bottom get infinitely close to? So you get 0 over 0. Does that mean anything mathematically? No, until you simplify it into get something that's so close it has the same behavior. It's not exactly the same, but it has the same behavior. This is the phrase I want you to remember, indeterminate form. If you try to plug in 2, you get 0 over 0, which is an indeterminate form, in which case you need to do some sort of simplification. You need to do some sort of simplification. So let's practice some of this simplification. Let's practice some of this simplification. Take a look at this one, everybody. Can you plug in 4? It does. It absolutely does. Fantastic. So this goes away. Leaves you with the limit as h goes to 4 of h minus 1. What's that equal? 3. Excellent. Excellent. Oh, so much fun. Very cool. Let's take a look at b right here. Let's take a look at b. Does this one look a little different? Just look at the numerator. If you wanted to simplify the numerator, what would you want to do? find a common denominator, then do what? Well, you find the common denominator, right? And then you do what? You multiply the top by a form of 1. You gotta be careful, right? You gotta be really careful. What you do to the top, you have to do to the bottom, or you just multiply by a form of 1. What I mean by that is the following. What is the common denominator up top? What is it? 3 plus h times what? Times 3. Now here's the thing. Can you just multiply the top by 3 plus h over 3? No, you can't. So if you multiply it up there by this, what do you have to do on the bottom? 3 plus h times 3. Is everybody with me so far? If you multiply the top by something, you have to multiply the bottom by the same thing. What does the bottom become? Be very sorry, the top. Limit as h goes to 0. What does the top become when you multiply this into here? What happens when you multiply that in? What does it become? What? It becomes 3. Look, 1 over 3 plus h times 3 plus h times 3 over 1 minus 1/3 times 3 plus h times 3 over 1 all over h times 3 plus h times 3. All I've done is I've multiplied it in. That's it. All I've done is I've taken this and multiplied it in. What happens? What cancels now? Tell me one thing that cancels first in the top. The 3 plus h's cancel. What else cancels up top? The 3 cancels with the 3. So let's simplify just the top right now, just the top. What does the top become? 3 minus what? 3 minus 3 plus h. What's the bottom? 3 times h times 3 plus h. Are you with me so far, everybody? You have the limit as what? H goes to 0. What happens up top? You end up with the limit as h goes to 0 of what? H over 3 times h times what? 3 plus h. What now? What can I cancel? You can cancel the h's. Why is that super awesome? Now what do you have? Limit as h goes to 0 of 1 over what? 3 plus h. So what's that limit equal? What's it equal? What does it equal? 1/9. This is equal to the limit as x goes to 1 of 1 over x minus 1 minus 2 over factor first. We love factoring, right? If you did that first, do you notice something? Well, you have an x minus 1 on both sides, or both fractions. So that's the same thing as limit as x goes to 1 of 1 over x minus 1. What should I multiply this one by? Over x plus 1. Do I multiply the other one by anything? Nope. Why was I allowed to do that? What is this? What is that right there?
1.
That's 1. That's just a fancy form of 1. You're allowed to multiply by 1. Does that make sense? Why did I do that? What am I trying to build? What am I trying to build? A common denominator. Yay! What does this fraction become? What does the first fraction become? X plus 1 over minus 1 times x plus 1 minus 2 over, oh, do we have a common denominator now? We do. So now you can just do the operation in the numerator. What does it become on top? Limit as x goes to 1 of x what? Over, oh, the common denominator that we had. But what's the magical thing? What's the magical step now? They cancel, leaving you with the limit as x goes to 1 of 1 over, which is exactly. I'm going to rewrite this without factoring and see if you can see it. Am I allowed to do this? So, not plus, sorry. I'm not allowed to do that. Have I changed anything? What's the square root of x squared? What's the square root of 2 squared? Sorry, what is 2 squared? 4. But what is now recognizable? What is this right here? What is this thing at the bottom? That's the difference of what? Anything is the difference of squares. It's not necessarily pretty. Is this pretty? It's debatable. So what do you end up with? The limit of the square root of x minus 2 over what? Square root of x plus 2 times the square root of x minus 2. What cancels? Oh, that's gone. Leaving you with the limit as x goes to 4. Was it 4? Yeah. Of 1 over the square root of x plus 2. What's that going to go to? 1/4. So what's the trick here? If you have a minus b, what is that always factorable into? The square root of a plus the square root of b times what? The square root of b. You can always just take the square root. Is that always useful? No, it's not always useful. But it's a trick you need to remember. It's a trick you need to remember. Exciting. Okay. Let's go to the real fun one here. Take a look at this. What's new about the form of 1? I'm giving you a big hint here. You're doing the limit as h goes to 5 of this thing right here, h plus 4 minus 3, and you need to multiply by something that's the same on the top and bottom. It's the same thing here. This one times 3, what's that? Plus 3 times what? 4. Hey, and then you get this one. What's that one? Minus 3 times the square root of h plus 4. And what's negative 3 times 3? Hey, does something cancel there? What cancels? Yay! Is that nice? So what's the top? The limit as h goes to 5. What's still left there? H minus 5 times what? Square root of h plus 4 plus 3? All over what? H plus 4 minus what? Minus what? Minus 9. Can we simplify the bottom a little bit? Can we simplify the bottom a little bit? Yes, we can. What does the bottom become? Oh, wait, does something cancel now? The h minus 5s cancel. Is that awesome, super cool? So what do you have? The limit as h goes to 5 of the square root of h plus 4 plus 3. What does that become? 6.